Let's talk about solving absolute value inequalities. So as a reminder, the term absolute value is referring to the distance to 0. So when we look at the distance, we're going to be looking at whether the absolute value or the distance should be less than a number, so it's going to be close to the center, or whether the absolute value or the distance is greater than a value. So we're going to be looking at numbers that are away from the center. So we will solve the absolute value inequalities and then use the understanding of it, meaning the term distance, in order to check the meaning of the solution. In this first one, we have the absolute value of x is less than 4. That means the distance to the center has to be smaller than 4 units away. Well, if the center is at 0, then the numbers that are 4 away from 0 would be both positive 4 and negative 4. I'm going to use open circles on these to indicate that it shouldn't be equal to 4, but it's a distance that's less than 4. So I can go within 4 to the right or within 4 to the left, but it would have to be any value between those two numbers. That would be any number that has a distance less than 4. So it could be anything from negative 4 is less than x is less than 4. This is something that we call an and inequality because it has to fit both parts of the solution to be a part of our answer. So it's a number that is greater than negative 4, and it also has to be less than positive 4. So you can write the inequality as a combined inequality, as you see here. Negative 4 is less than x is less than 4, or it can be written as two separate inequalities. X is greater than negative 4, and it's less than 4. As an interval, you're going to see negative 4, comma 4 in parentheses. Parentheses instead of hard brackets to indicate that it's not equal to it. In our next one, instead of looking at the distance to 0 being our center, now we're looking at the difference between x and 3. So some number that is away from a center of 3. The difference between our number and 3 must be less than 5. So if I go 5 to the right, I'm at a positive 8. Or if I go 5 to the left, I'm at negative 2. A distance that is less than 5 away would be anything from negative 2 to 8, not including those numbers. So again, you can write an inequality as negative 2 is less than x is less than 8. Or you can write that as x is greater than negative 2 and x must be less than 8. It satisfies both of those inequalities in order to be a part of the solution. As an interval, it would be negative 2, comma 8 in parentheses, again to indicate it does not equal to it. In our next one, we now have an absolute value that is greater than or equal to 2. So this would be the same thing as saying the difference between x and negative 2. So x minus a negative 2 is the same as x plus 2. So now we're looking at the center of negative 2. I want a distance from the center that is greater than or equal to 2. Well, exactly 2 away would be at 0 or negative 4. But if I want a distance that is either equal to or greater, I would have to be further away from the center to have a distance greater than 2 away. So we have two separate inequalities here where x is less than or equal to negative 4 or x is greater than or equal to 0. So notice I switched to using the word or instead of and. If I want the distance to be bigger than 2, I have to be further away from the center. So it can be anything further away than negative 4 or away from 0. So we are less than or equal to negative 4 or greater than or equal to 0. That means any number that fits into one arrow or the other can be part of my solution. In an interval, this would be negative infinity, comma negative 4, where you would have a hard bracket on negative 4 to indicate it can equal it. And then the union symbol for or. And this next section would be 0, comma, infinity for the right side. It's not always going to be easy to just use the number line to solve, so we also want to know how to set these up algebraically. You're always going to isolate the absolute value bars first. So I'm going to start by dividing by negative 3, since negative 3 is getting multiplied by the absolute value. Be careful to never multiply your negative into the absolute value bars. So we have the absolute value of 2x plus 1 is greater than negative 4, because when I divide by a negative, my inequality symbol flips around. From here, we're going to split it. 2x plus 1 is greater than negative 4, Because it's a greater, we know that that's an or. We want to be away from the center, so we have two options away from the center pointing outwards. 2x plus 1 is greater than negative 4, or 2x plus 1 is less than positive 4. So when we solve those for x, get x is greater than negative 5/2, or x is less than 3/2. So again, going back up to the top here, a distance greater means I'm going to be away from the center. That's why I'm using the word or to indicate that it can be away from to the right or to the left. A distance less than means I want to be closer to the center, so I have to be between those two numbers. So I use the word and to indicate that it has to fit both of those arrows. It has to be both greater than the left side and less than the right to trap it in between those two. This is one that should be an or, which normally looks like two arrows pointing opposite directions. Here I have greater than negative 5/2. Well, that's negative 2.5, so that would look like this, pointing this way. Or x is less than 3/2, which is 1.5. Well, that's this arrow pointing this way. So that looks a little bit different than what we're used to. So this is where we want to analyze the solution's meaning. A solution is a number is part of the solution if it fits into one of these two, if it's either bigger than negative 2.5 or if it's less than 1.5. But if you look at our number, every single number on the number line fits into at least one of those arrows. This arrow right here is going to cover all of your positive x values. Everything that's positive is bigger than negative 2.5. This arrow is going to cover all of your negative values. Everything that's negative is less than 1.5. Every single number is covered, therefore your final answer is actually going to be all real numbers. That anything from negative infinity to positive infinity is part of your solution. There we could have gotten that from this step right here. The absolute value is greater than negative 4. Well, anytime I put something into the absolute value, it's either going to turn it to 0 if it's already 0, or it's going to turn a negative into a positive. So the absolute value at the lowest will always be a 0. Well, 0 is always greater than negative 4, so any number I put in here would make that situation true, which is why your solution is all real numbers. A couple other kind of weird solutions that you could get. On this one, we have the absolute value bars by themselves already, so we can go ahead and set up our two inequalities. Greater is going to indicate the term or. I want it to be greater than on the right side, or I flip that to be less than or equal to for the left side, negative 3x plus 1. That's where we switch the inequality and we switch the sign. So when I solve this, I'm going to add 1 to both sides and subtract x from both sides, and then divide by 2. So I have negative 1/2 is greater than or equal to x. But you can also read that as x is less than or equal to negative 1/2. Or on this other one, I'm going to add 3x, so I get 4x, and I'm going to add 2 to get 3. To get x is less than or equal to 3/4. So I need to be less than or equal to negative 1/2. That is going to be right here, pointing out this way, or less than or equal to 3/4, which is right about here, pointing this way. So again, that ends up kind of being different. If it's an or, to reiterate, you have to fit into one of the two arrows to be a part of the solution. Well, if you notice, this arrow at the bottom here, less than or equal to negative 1/2, that entire arrow is kind of unnecessary because this part of the solution, less than or equal to 3/4, covers everything the other part's already going to cover. So it's not that this is necessarily wrong, but it's not necessary as part of your solution. You really only have to state that x is less than or equal to 3/4. Because again, anything less than or equal to 3/4 will already cover these numbers right here. Less than or equal to negative 1/2. Those ones are already smaller than 3/4, so I don't need that second statement. As an interval, that would just be negative infinity to 3/4 with the hard bracket. And your last one, we have x plus 1 is less than or equal to 2x minus 2. And then we're going to use the word and for our second one because we have the absolute value is less than. So now I want to be between my two values, bigger than the left side and smaller than the right side. So the right side now, x plus 1, or this would be the left side, excuse me, is greater than or equal to negative 2x plus 2. It's going to switch. So when I solve that, I'm going to subtract x and then add 2. I get x is greater than or equal to 3. And on this side, add 2x and subtract 1. So when you simplify that, x is greater than or equal to 1/3. So I want to be greater than or equal to 3, which are these numbers, and I want to be greater than or equal to 1/3, which would be these numbers. So let's analyze that solution. And means it has to fit both of those in order to be a part of the solution. I have to be bigger than 3, and I have to be bigger than 1/3. Well, these numbers don't fit both of the solutions. Those numbers there are bigger than 1/3, but they're not bigger than 3. So really, the only thing that's going to work is going to be this section of your inequality. So x is greater than or equal to 3 would be your final solution. That's going to cover everything from the other arrow with the overlap. But again, I can't cover this in between because that only fits one of the arrows, not both. In an and situation, a number has to fit into both in order to be a part of the solution. So your solution here would be a hard bracket to indicate it can be equal to 3 all the way up to infinity. So not every problem is going to have a unique solution like that, but it is important when you get to the final answer to analyze what it actually means rather than just finish solving and circling your answer.